Okay, hello, week 7, 11 people, 12 people. I think I'll just have to confess up front, I'm afraid I am suffering from crippling insomnia and have been all week, so I'm not at my best. If I do something stupid, just tell me, because I'm a bit out of it at the moment. Anyway, I hope you enjoyed the spaceship exercise. It's one that I find, to me it's not hugely difficult, but it does contain subtleties, and that can be a problem, and I think it catches people out when they try and do it and realise that it's not all just working, there's like little niggly things. But that is very much life. That's what writing computer programs is like. So get used to it. Right. And as you hopefully remember from last week, you already know the suspense about what this week's homework is going to be has been broken. You already know that it's Breakout. That was partly to kind of give you a head start. Has anyone taken that opportunity to look at it ahead of time? Look at the exercise. Anybody actually implemented stuff as well? Done. You see, this is what I have to deal with down here. Well done. Okay, well, it was just an opportunity in case you had time at the weekend, because I do want you to put more effort into this one. It's worth more points, so I was hoping that just if I give you a bit more time, it's a chance for you to have a go. So that's what this week is all about, just about Breakout, and this lecture today is just about kind of hints and tips about things you could do to make the Breakout homework good. So let's get to it. Right, one thing to say about Breakout is, up till now with Pong, you had your two paddles in the ball, and those are kind of obvious simple objects. You could tell what they were. They had positions and maybe sometimes velocities. It was quite easy to think about them. One of the things that happens with Breakout is you've got all these bricks, and the naive thing might be to think that you need a bunch of brick objects, but to me one of the big insights is that you should think of the wall as being the object here. It's an object of a higher level, a more kind of abstract container object. This is something I've tried to talk a few times about this thing. I presume you are all taught that object orientation is still the preferred paradigm. Is that the case? That's still seen as, is it still cool? Or have they started telling you that actually it's not as cool as they made it out to be and they've all been lying to you? Which is it? Yeah, okay. The whole question about the merits or otherwise of object orientation is actually a big, interesting subject that I might talk about a little, but broadly speaking, I'm in favour of it, and I know that it's still the dominant teaching paradigm. I will just tell you right now, in case I forget, there are some game programmers who don't like object orientation and who think that it's bad for games. If you look up a thing called data-oriented programming or architecture, you'll see some people arguing that objects can lead to inefficiency and overkill. The case that those people make, I actually think, is itself exaggerated, but these are people doing very low-level console stuff where you have to be super efficient, and it turns out if you've been super efficient, you tend to go for really simple things like big, dumb, contiguous arrays of numbers rather than adding object overheads. But we don't have to be like that because we're doing stuff that is well within the capabilities of a modern machine. We're not fighting against performance bottlenecks. Nevertheless, there is this matter of discretion when you work with objects about deciding what are your objects going to be, what's the granularity of your object. You have these ship of Theseus problems about what it means for objects to be something and to be equal to each other. But to me, the big trick when you're doing Breakout is just realise that you have the choice to say that the wall is an object, and if you do it that way, it becomes quite simple. You've got just one dumb object, that's the wall. The bricks are just internal details, and if you do it that way, it turns out to be easier to think about it and cleaner than if you'd said, I'm going to have to create 30 brick objects and stuff like that. Among the things that this helps with is it makes the collision detection easier. If you had created separate brick objects, then what would happen is whenever the ball moves, you'd have to check for collision against the bricks. So you'd need a loop where you'd have to go and collision check against every one of your 30 or however many bricks you've got, and in every case have to do some kind of check. You would get away with that given how fast computers are, but that is essentially a slow thing to do. Right? That's an order n operation. You're linearly scanning through all these things and checking each one. And I think in your brain you should sort of realise That seems unnecessary though, because you kind of look at the screen and it's like, I already know which brick it's going to hit. There's only ever one obvious one. It's the one that's right next to it. Why am I having to check all these other ones? I know it's not them. Well, if you use the wall idea, that allows you to very easily zoom in on exactly the brick that you care about in an efficient way. So that's one of the ways in which having a wall helps. Now, you could argue against this. You could say, well, the wall is an oppressive hierarchical structure, denying the bricks their individuality and all that kind of thing. Try not to say anything about social justice warriors and all this kind of thing. I get myself in trouble. So yes, it's true. The wall is a hierarchical, oppressive structure. Don't say patriarchal. And that's just the way it is. Okay. Sometimes that's how things are. Are you familiar with The Wall, Pink Floyd? Seems very apt, just another brick in the wall, and dark sarcasm in the classroom, teacher, leave those kids alone, all that kind of stuff. You have seen the video, I take it? Yeah. So I don't need to spend 3 minutes showing you the video, but you get the idea. I have a personal peeve about this song, which is that one of the lyrics is, "We don't need no education." Now, it sounds like you've got it ahead of me. Obviously, in standard English, we don't need no education. It's a double negative, so that actually means we do need education. So that is correct. So either they know what a double negative is and they're being ironic, or they don't know what a double negative is and they're just being idiots. In which case, they need education.
I bet they could care less.
Well, yes, exactly. That's another good one. So you do need education because it's a good thing, and I'm glad you're here today, getting what passes for education nowadays in the modern university. I'm too tired, I shouldn't be doing this. Right, I need arrays. The natural way to express the wall is as a two-dimensional array. That should be fairly obvious to you. So that's just an array of rows, where each row is itself an array of columns, I guess, or elements of a column that are the bricks. Quite simple. Now, multidimensional arrays are an interesting thing in programming languages. Some programming languages have got greater or lesser support for them. The way they work in JavaScript is the really naive one. It's just kind of what you'd expect. A two-dimensional array is an array of arrays. That's not always the case. If you think about C has got like a concept of multi-dimensional arrays, but actually it's really just one linear array, and it does a little bit of arithmetic. So when you give it two indices, it does like a multiply and an add to find the single index. So it's done as a linear thing. But JavaScript, in part because it's got dynamic arrays that can be any size and all this kind of thing, doesn't do it that way. So it just does this. Like, it is literally an array that contains things that are arrays. And that allows some slightly curious things in that you can have a 2D array where the elements are not all the same size necessarily. This would be what you would call a jagged array, which is maybe sometimes flexible. Like in C, you couldn't do this really. In C, your array would have to be, it would have to be like a 5 by 8, and that would be it. It would be just totally regular. In theory, in JavaScript, you could make it be, arbitrarily sized arrays inside each other. You don't actually need that for Breakout because naturally the structure of Breakout is indeed a totally regular grid. But I'm just mentioning that fact about the language. Okay, let's talk about bricks. So you could say, we've got the wall object and it contains the bricks, and the bricks themselves might be represented by brick objects. That's a thing you could do, right? But there are reasons to not go that far. One thing you should think about if you're going to make an object is to say, an object, you think of it as it's got some state, it's got some data members, and then it's got some methods. And of course, the classical idea is the data is kind of internal properties of the object that are kind of its responsibility, and methods are ways of talking to the object and making it do stuff with its internal state. Right? That idea, a bit like it's a cell. The cell's got stuff inside it, and it's got messages that can come in that tell it to do things, and that's kind of how they operate. So we'll think about that and say, well, if you had a brick in Breakout, what would its data members likely be? What are the unique attributes that bricks have got? Maybe someone up the back could volunteer an idea. What's that?
Position
A position, right? Okay. So like it's
array index of position anyway though.
your problem is you're too good, right? Just ignore that you heard that. Right, a position, so like an XY position. That sounds sensible. That'd be one of the things a brick would have. Anything else?
Well, they're all the same size, so that would count as unique.
Correct. They don't really need the size. So what else? What have they got that might be unique about them though?
Okay.
Keep going.
I feel like if they have been destroyed or not.
Brilliant. Yes. Whether they've been destroyed or not. Now, there are actually two ways of thinking about that. You could say that, well, if it's been destroyed, you should delete the object and it shouldn't be there. But the other way is you could have an object that it's still sort of there, but there's a flag on it that says, oh, by the way, I'm dead. Yeah. And that actually is a good idea for Breakout. So yes, it might have like a am I alive flag, and you could say it has a position, but the position is implicit. If you already put it inside a grid, if you put it inside an array, the position is implied by where it is in the array. So if you also stored that inside the object, you'd be kind of repeating yourself. You'd be saying that inside the wall, it's row 2, position 3. And if you also say that inside the brick, there's no need to say it twice. In fact, saying something twice is just an opportunity for error, because now you've created the possibility that those two things might not agree with each other. And now you've got bugs and problems. So it turns out, because of the grid structure, the position is implicit and you don't need to store it. So it doesn't really have a position, even though it does, but it doesn't. It just has the simpler thing, like am I alive or dead? So I think there's a parallel here with pixels when you're drawing the screen, right? A pixel has sort of got a position and a colour, right? But an individual pixel doesn't actually move. If you show a dot moving across the screen, you're not taking a pixel and changing its XY coordinates, right? You're just dealing with a whole bunch of different pixels. Yeah, it's a trick. So the pixel doesn't really have a position. So it doesn't have a lot at all. And it's the same thing. You wouldn't make a pixel an object. It's not heavy enough. It doesn't deserve to be an object. It's basically a piece of data inside another object. So a pixel is just a piece of data inside a frame buffer. And in the same way, a brick is really just a simple piece of data inside a wall, I would claim. Unless you do something fancy. If you do something fancy, like you have your bricks all independently oscillating or something like that, maybe they need more information. If you have bricks that that fall out of the wall periodically, they would need to have their own idea of position, and you could maybe add that optionally. But in a simple case, they don't need it. So that's it. The only thing that the brick really needs to know is whether it's alive or dead. There could be other things, by the way. If you made them multicoloured, it could maybe need to store its colour and that kind of thing. So there are a few things, but they're all simple enough that they're just what we would call plain old data, rather than something that needs, all the ceremony of an object and methods and all this kind of stuff. It's not really needed. So I'm kind of alluding to a principle here called Occams Razor. How many of you have heard of Occams Razor? You all have, great. So how would you describe Occams Razor? Brilliant, the simplest thing. That's what it is. So it sounds like you already know. It's named after this guy William of Occam, who had this principle that entities should not be multiplied beyond necessity. The idea is it's kind of invoked in science, where we say if you've got multiple hypotheses that all explain your data, you pick the simplest one. It's a kind of a natural preference, and to some extent a supposition that the simpler one is probably more productive, and it's probably more true. That the simple thing probably catches the kernel of an idea. So the basic principle is keep it simple. That's what Occam tried to tell us. Sometimes called keep it simple stupid, or the KISS principle. Often quoted as entities should not be multiplied without necessity. And actually, if you ever read Bjorn Stroustrup's book about C++, have any of you read that book or got that book?
No, but I think I know the poster.
Yeah, and in the chapter where he introduces object orientation, he actually starts with that quote, that objects should not be multiplied without necessity, which is an attempt to kind of counteract the potential excesses of going mental with objects. So my point is that bricks don't need to be full objects. In fact, what's good enough for them is often a simple integer. For example, imagine if your bricks only need to remember, if you keep them inside the rigid grid, you do need to know whether they've been hit or not. So that would just be like, you could use a Boolean there, you could have true or false, but it's kind of annoying to have to write true or false. So this is one of these cases where I would just say call it 0 and 1. and it's easier when you're like typing out the array longhand that you just see zeros and ones. So 0 and 1 is enough to let you know. Or if you do what I did a simple version of this where I allowed the bricks to have colours as well. So you would encode the colour as a number. So 0 would still mean a dead brick, and 1 would mean, it's red, and 2 would mean it's blue. So again, you don't actually store the colour because that would be a bit repetitive and verbose. You just store an index, 1, 2, 3, 4, and then you look them up in a table somewhere else that tells you what the RGB values are for those things. So often a very simple integer is enough to represent the information that you care about for your brick.
That's enough to also describe the interaction with your brick.
Yes, you can also use an integer to encode information like how many hits this brick would take before it's destroyed if you do multi-hit bricks, or you can maybe even encode things like, does this brick drop a special power-up? There's quite a lot of things you can fold inside an integer, especially if you play a couple of tricks. So that's one part of it, right? So the other thing that's worth talking about is collision detection and collision response, in fact, in Breakout. Now, proper collision is a genuinely difficult thing, and we've got a whole week of lectures coming up that are all about how to do collision stuff in somewhat proper ways. And luckily it turns out that with Breakout we can take a few shortcuts, a bit like with Pong, but perhaps slightly different, that allows us to produce something that's good enough for Breakout, even if it's not like totally perfect. One thing you can do is if you just treat the ball as being a point, so now you're just dealing with a point brick collision, so that's like a point rectangle collision, and working out whether a point is like inside a rectangle is pretty simple, isn't it? It's between the two x values and between the two y values. If it's within that range, it's in the rectangle. So that's how you tell if a hit has occurred at least. And because you've got the regular structure of the wall, that allows you to narrow down your interest to the particular brick that you're near very quickly without having to iterate through all of them, as I said earlier. So it turns out the concept I have for this is something I would call brick coordinates, where you just imagine the brick's position in the array as its brick coordinates, row 2, column 3. And all you need to do is take the pixel coordinates of the ball, which is what you'll know, convert those pixel coordinates into brick coordinates, and then do a simple array lookup, and then you can see whether is that brick alive or not. And if it's alive, you have to kill it and bounce off it, and if it's already dead, you keep going because it's not there. It's got a 0 in it.
It's effectively a hash table. With the ball being the hashing function.
Well, if you insist on thinking about it in those terms.
No, it seems logical to me.
I would say it's simpler than that because it's just arithmetic, but I know what you're getting at. I know the intuition is a mapping. So anyway, this is what you end up having to do. Another piece of code I'm just giving you so you can type it in if you haven't been able to figure it out. You would take the x position of the ball. You have to offset it from what I call the wall base. So that's whatever is the initial x coordinate of the whole wall, which might not be 0. You might have put it in a little bit. So you just do that. Divide it by the brick width, and that tells you how, or in fact, the brick separation is actually divided by the gap between one brick starting and the next brick starting, which might be the width plus any gap that you have between them if you put a gap in. But it's that separation. Divide by the separation. I do an analogous thing for y, take the y position, divide by the height, offset it by the base, and then importantly, use floor to round it down to an integer. What would happen if you didn't use floor to round it down to an integer? It would sometimes be a floating point value, and then you would go and look up an array with a floating point index. And what would JavaScript do when you do that?
Create a new index in the array.
Not quite. If you're reading it, it won't do that. If you wrote it, it would create it. If you read it, it'll just say undefined. But the annoying thing is there that they end up getting undefined that flow through your program, and you tend to not be able to see them until it ends up doing something, like tries to draw them, and then you might get your context complaining that you've passed an undefined to a drawing function, or it might just not tell you anything, and you would just end up with a collision system that was really wonky. It would only work under perfect situations, and things would just go through it. Why is it going through it? It's going through it because it's looking up phantom floating point numbers in your array, because JavaScript is an excellent programming language. So just remember to put the floor on it. Once you've detected that there's a collision, you have to think about the bouncing part, which is nearly as simple as Pong, but not quite as simple as Pong. The main thing you need to detect with the brick is that if you were hitting the brick from below, then it would just be a bit like when you were hitting the paddle. It's just a simple inversion. So you hit the brick from below, you just invert the Y velocity, and it'll come back pointing the other way. But you might hit the brick from the side, in which case you want to kind of bounce that way instead. Assuming that you make the distinction, some versions of Breakout don't bother with this, they just treat everything as if it was a collision from the bottom. But if you want it to be reasonable, you want to identify edge hits, because they matter towards the end when you've cleaned up the wall and you're hitting things from the side. So you have to detect whether it's a bottom hit or an edge hit. So here's the example, your brick's here, your ball's here, and you're coming in at some velocity. The question is, did I hit it at the bottom, in which case I need to do the Y flip, or did I hit it at the side, in which case I need to do the X flip? Well, it turns out a lot of the time you know really easily what the answer is. If, for example, the ball's initial position is in here or in here, then it's obviously hit it at the left side. It can't do otherwise, right? So that case and that case are trivial. And that case and that case are trivial. If it's either of these, it has to hit it at the top. So the only cases that you don't know automatically are these sort of cornerish cases, because the problem with the corners is if the ball's in the corner to begin with, it could potentially hit it at the bottom or it could hit it at the side. And actually working out which it is, if you do it properly, is a little bit annoying, because you have to create a line vector and intersect it with the other line vector. And it's, oh God. There's an easy way that's nearly right and will work most of the time and is good enough, and that's just look at the broad direction of travel. Now you take this guy here, he's in the corner, so you have to figure out which of the two cases it is. But basically, if his x velocity is higher than his y velocity, then it kind of means he's going at a kind of lowish angle, so he's probably going to hit it at the bottom. That's not cast iron logic, right? But it's a rule that's mostly going to be true. Alternatively, if the y velocity component is higher than the x velocity, then that means he's going at kind of greater than a 45-degree elevation, which means he's kind of going up, which means he's probably hitting it at the side. So basically, all you need to do is just do this very little check about your x and y velocities and allow that to let you do the tiebreaker. And most of the time you don't need to bother. Most of the time it's obvious. Most of the time the x position is in this sort of section here, in which case it's obvious that it's hitting the brick from below.
If you want to do it properly, do you really need to look at the line segments? Could you just do some basic trick to figure it out?
I'm saying the line segments because logically it amounts to the same thing. Yeah, but yes, because these are vertical lines, they're simplifiable. So have you got a particular idea as to what the simple way is of knowing?
I mean, because it's easy to calculate how far it is from the corner, like what the direction is to the corner. So you can calculate the angle.
Would you literally calculate an angle?
No, you calculate the ratio using, you calculate the sine or cosine.
Yeah.
And then you compare it to the angle its velocity vector is making.
You're probably right. I can't see it in my mind's eye exactly, but yes, there will be shortcuts here where you do something that's a bit like a dot product or something like that. Yeah. And it'll tell you. But I'm conceptually saying you're kind of working out which of the two lines it intersects as an easily understandable version of what the geometry is, even though you might have shortcuts. So you're probably onto something. The other thing you can do is, of course, if you don't want to do any of that, just assume that it's a top-bottom hit, because it usually is. In fact, I would say that if you just assume the top-bottom hit, that's acceptable for the minimal version. Remember this breakout thing? There's a minimal version that will get you 50% of the mark, and then if you do cool things, you go above that. So you could claim one of your cool things is you've done non-trivial collision. You've detected the difference between bottom and edge collisions, and that would be something I would accept as a very basic coolness point, one of the simpler ones, and then you'd have to do things that were fancier than that. So that's just what I told you. The other bit of bouncing that happens is when the ball hits the bat. Now again, that could be really simple. You just always do the Y flip, but some people like to do the thing where, for example, the velocity of the bat might be imparted to the ball slightly, so you can kind of, the ball comes down, and if you're going fast underneath it, you kind of get a wee bit of extra velocity as it goes. And that's just a matter of knowing whether your bat's moving and having some bit of logic that, just adds a little nudge onto the rebound. It's one thing you could do. The other thing you could do is, some versions of Breakout, they do this thing where if you hit the bat towards the edge, the angle that it bounces off is sharper than if you hit it in the middle. It's a bit like, well, before I get into that, I'll just show you the basics. So in the general case where if you're hitting off a bat, you're technically doing, an angle of incidence equals angle of reflection type of thing that you get in optics, when light rays bounce off mirrors and stuff. So you have a thing that's coming in at a certain angle and it goes out at a certain angle. And if it had just kept going, it would have kept going at the same magic angle. So it's all about flipping this little angle around, right? That's what you do in like the totally general case. Here's a high quality visual aid that I constructed at great expense. Imagine you taking your bat and you decided you wanted to give it kind of the appearance of angled edges. In fact, you may actually draw these edges. Maybe you would draw your bat as a trapezoid, is the word, rather than just a rectangle to show it's got little edges. And if the ball hit the edges, the bounce is a bit different. If it hits here, it's easy. It just does the Y flip thing, which we already know how to do. But if you hit it the side, it does the slightly weirder thing. That's not an obvious, it's not just an obvious flip. What's going on is you are doing a angle of incidence equals angle of reflection bounce relative to this little vector here that I've labelled n, which is n for, does anybody know?
Normal.
Who said it?
Normal.
Who said it? Raise your hand. Yay, well done. A new person, I think you're new, to join the conversation. Welcome. Yeah, it's a normal vector. So I hope you all know normal vectors. It's just the perpendicular thing. You've got a shape and you take the part that's perpendicular and you point out the normal and you size it so that it's worth 1. It's a unit vector, a vector of length 1, because that just makes things easy. So this is what you do. You'd have a normal vector that is the perpendicular of this thing, whatever it is. Looks like it's a 45-degree one in this case. And you need to find a way of flipping this incoming vector, which is the the velocity of the ball, or yeah, it is kind of the velocity of the ball. You need to flip it around here. There's a little bit of geometry involved in doing that, and I'll tell you quickly what it is in case you're maybe wanting to try it. Basically, what you need to do is, of course, you come in here and you do the flip and you come out here. So the resulting vector, this one here, the effect is as if you've kind of kept going along this sort of invisible line here, somewhat. That you come in and you bounce and you come out here and you've kind of travelled along there in some sense. So it looks like that. If you take this incoming vector, remember with vectors, you're allowed to decompose them any way that you like. You can break them up into other vectors just as long as they add up to the original, and you decompose them in ways that are just convenient for you, convenient for whatever maths you're doing. Now, because we're doing things based on the normal here, it is convenient to take I and break it up into two components, A and B, where A is the one that's going sort of tangentially here, and B is the one that is going along the normal. So B is just the normal vector scaled up to whatever the actual size needs to be, right? So I've just said, I declare that the incoming vector I has got two parts, A and B, and what I want to do when I'm going out is to have this vector that would go from here to here. It's kind of one I haven't shown yet. A vector which is, if you start from here and you want to get to there, what do? Well, you do minus B plus A to get there. So that's just A minus B, right? So this exit vector here, the one we want to calculate, is actually A minus B. So if you do the maths on it, you need to know what B itself is. Well, B is just, the thing about B is you've decomposed the I vector along this axis. And I hope you just know that the way you decompose vectors is you do dot products, because a dot product of two vectors is the magnitude of the first vector times the magnitude of the second vector times the cosine of the angle in between. And multiplying by cosines, you should think of it as like a way of flattening things, right? So if you took I here and you multiplied it by this cosine, it would in fact collapse down here. So basically the dot product of I and the normal vector here does in fact give you the value of B, the scalar magnitude of B, and then you multiply that by n to actually, take the directional part of the vector. It's one of these things, if you don't know it, that probably won't teach it to you, but if you vaguely remember your geometry, it will sound familiar. So B is just the dot product of I and n multiplied by n, and A itself is I minus B. Again, if you just go and look at the angles, it's just a simple triangle. I minus B is A, that's fine. And R, the reflection vector, as I just said previously, is actually just A minus B, right? So that's basically the components of this. You will usually see this all packed together into one expression. This is me building up from its parts. You pack it all together and you just say R equals A minus B, given that A equals I minus B, so that becomes I minus B, so that's I minus 2B, and B's this, so it becomes I minus 2 of this. So you end up with that. And that's the form that you often see it written as for how to compute a reflection vector. And it looks a little bit daunting if you do it here, but I hope I've explained to you that, look, it's just, just drawing lines, tail to head, stick figure, lines together, it's easy, and this is how it comes out. So that is how to do a fancy reflection if you felt so inclined. Okay, that's collision. Other cool things that you might want to do in Breakout is collectibles. Real Breakouts often have this. You hit a brick and something falls out of it, which you then put your bat underneath it to catch it. And you can have it be a good thing, like a laser, or a thing that gives you an extra ball or an extra life. Or you can have it be a bad thing, something that shrinks your bat, rather embarrassingly. In which case you have to avoid those ones. So it can be a thing where you need to color code the collectibles, some of which are good, some of which you want to avoid. There's lots of stuff you can do there. Arkanoid does a lot of this. It's what makes Arkanoid fun. You have lots of power-ups to play with while you're doing doing the brick killing. So that's the thing you might want to do. Doing that adds a new level to things, because you're going to have to, when you hit the brick, instead of just deleting the brick or setting its kill flag, you now have to make something drop. And in order to do it, you have to spawn a new object. You create a new object that's going to fall, maybe even fall under gravity, or maybe not. Whether you sometimes, should they go at constant speed or should they have gravity on them? Try it and see. So you have to create this new object, and it falls down, and it'll either just fall off the screen, in which case you detect that it's gone and you kill it, you clean it up, or it maybe hits the bat eventually, and when it hits the bat, then you have to call some kind of function to give the bat whatever power is associated with it. Bat make longer, bat make sticky. Sticky bats are a good thing. So that's one of power up is to make it so that when the ball comes back to the bat, it just stays on it, and that way you can move it to a position of your choice and then press space to fire it again. Sticky bats are a kind of interesting thing to do. You have to do that when the ball collides with the bat. It needs to detect its position relative to the bat and sort of remember that, and then just keep adjusting its own position so that it sticks to the bat until you clear the flag that makes it launch again. Just if you want to try it. But the basic thing here is that a collectible needs to be a new dynamic object, and that's a sort of fun thing to play with. Those of you who did things like the trails on Pong will already know how to do that kind of thing. You'd create an array, probably, G collectibles, so you could have more than one at a time, and you spawn things into that array, and you update them all, and at some point you check whether they've outlived their usefulness, have they fallen off the screen or have they hit the bat, at which point you delete them somehow. We'll get onto that in a second. So yes, if you're going to have things like collectibles, you want some kind of way to manage them, and I would say that that's like an array is the obvious thing in this case to use for that. In fact, there's a certain sense in which you really want a list, but JavaScript doesn't have lists as a natural built-in. Some languages do, like Python, lists just kind of come with a language, but JavaScript doesn't have that. So what you use is you tend to use an array and make the array behave like a list, which means you need to have ways to be able to put things on at the end and take things off at the front and do other listy type operations. It turns out a good way of doing listy type operations on arrays is a thing called Splice. How many of you are familiar with Splice? Okay, some. Anyone not familiar with Splice? Also some, and then some people with no opinion. So Splice is a good thing to know. It's a great way of being able to delete things from arbitrary positions inside an array without leaving a hole. Like with a standard JavaScript array, if you just go and delete element 3, then you delete element 3, but that means that element 3 is now undefined, but all the other elements are still there, and the size of the array is unchanged. Sometimes what you want to do is delete an element and have all the ones to the right of it be kind of pulled into the gap, and that's what Splice does. So here's an example. I have an array of foods: apple, banana, carrot, dog, elderberry, which your mother smells of. And here's one where and you just print it out. That's the echo. And if you do Splice, what happens here is the Splice has taken out the dog and left us with these. But it's like, it has deleted the dog and it shifted the other ones down. So elderberry has gone from being element 0, 1, 2, 3, 4 to being element 0, 1, 2, 3. It really has changed position in the array. The mechanics of Splice, by the way, are worth mentioning. What happens is this first parameter here tells it where it's to start cutting them out, and this tells how many to cut out. And you think of the start position as not being the elements themselves, but as almost being the gaps between the elements, in a sense. So you start with 0 is here, just before apple. 1 is here, 2 is here, 3 is here. So position 3 is just before dog, if you like. And then if you delete 1, it says you cut out 1 and you would cut out the dog. If you did delete 2, it would cut out 2. But usually with what we're doing, you're deleting 1 at a time. So you're splicing out 1 element. And this is what you would do if you had your array of collectibles, and in the course of the update, you realised that one of those collectibles had been collected, or had fallen off the screen, or had timed out, or whatever it is, right? So you do the logic, say, oh, this one should be dead now. What do I do? You splice it out of the array.
It's probably good to mention that if you're doing this in a loop, you may want to go backwards.
It's as if you wrote these lectures. It's amazing. Have you seen these before? Yes. But be careful if you're deleting things while you're looping over a collection. Because, what's your name?
Jan.
Jan? Yeah. As Jan says, if you delete something while you're looping over it, it can go wrong. The problem is, imagine you've got a loop counter, and you were iterating here, you're going 0, 1, 2, 3, 4, and you're on 3, and you realise that, the dog should be dead now, so I'll delete it. Right? The problem is, once you've done that, elderberry has moved from position 4 to position 3. So if you now update your loop counter and go from position 3 to position 4, you skip over the elderberry, which you don't really want to do. So there are a couple of ways around that. I hope do you understand what I'm saying? That if you delete something, there's a side effect that it kind of shuffles everything up, which means if your loop keeps going, you're going to do a skip that you don't want to do. And that'll cause an annoying little bug, that sometimes things won't delete properly because you've skipped over them, right? So the trick there is if you're doing a delete, you need to avoid the skip. One way to do that would be when you do the delete, decrement your loop counter to compensate so that it kind of compensates for shifting everything back. The other way would be, instead of using a for loop where you always update the loop counter at the end, use a while loop and update the loop counter conditionally. So you only update the loop counter if you didn't do the delete. Okay, so those are 2 ways of doing it. There's a third way, which is maybe more elegant, and that would be, does anyone know what the third way is? The slightly more elegant way to avoid this problem? Oh, I can't believe you don't know. I'm kind of disappointed now. What is it?
I don't know if it's one that I thought of, just to keep, maybe that's not elegant, I don't know, to keep a running tally of which items you should delete and do that separately.
Oh, you could do the delete in a second pass. There are some systems where that might be what you would choose to do, but that wasn't the one I was thinking of. The one I was thinking of is if you scan through the loop backwards.
That's what I said initially.
I didn't hear you saying it out loud. Did you say it in your head?
No,
because I'm not entirely psychic.
By iterating backwards.
Okay, I'm sorry, I didn't hear you saying that, in which case you are again right. Yeah, if you iterate backwards, the nice thing is that when you do the delete and it shuffles things down, it's shuffling down ones that you've already processed, so it doesn't matter. So if you started here and did 5, 4 and deleted it, then you go back to this one, 3, no problem, it's still 3, you didn't move anything, 2, 1. So backwards iterations are a sort of nice way of avoiding the delete side effect. I would say the downside there is just that it's a little bit non-obvious. If a maintainer was looking at your code and would think, why has he written the loop backwards? Is he showing off? Did he make it? Why did he put the minus? And it's the kind of thing like a maintainer might not get and might try to fix and would screw it up. So I would say that's something that's non-obvious enough that you should comment it. Comments are a big debate in programming, of course. You don't waste your time commenting things, say, this is a for loop. Yes, we know that. It says for. We know what the language is, right? But comments should tell you things that are not obvious. And that would be something where I would say, backwards iteration to avoid delete side effects or something like that.
You can also do it the JavaScript way, which is stick everything in an if statement with the array index, because an undefined array index is a false value.
Let's not go there. No, that's a bad suggestion. I don't like that one. Okay, so that's the thing you need to do if you're doing dynamic objecty things. Power-ups, that's the flip side of collectibles. If you've got a collectible, when you hit it, it does something to you called power-up. So you can have power-ups or power-downs, bad ones. You can apply those to the bat, the ball, the players, whatever the hell you're doing. Basically what happens here is there's just some kind of simple function that you need to write, like you put a function on the bat object that implements the, as I say, the get bigger, get smaller, change color, whatever it's doing. And you just have some logic in the collectible that once the collision's been detected, it calls that method of the bat and it just triggers the right reaction logic. It's very simple, but I just thought I had to mention it. And yes, you can do kind of non-obvious things like sticky bats or speed modifiers. Remember we talked about that thing that sometimes when you hit the third row, it makes the ball go faster. But also remember that you shouldn't just do that every time it hits the brick, because then it will get faster. You need to do a flag where you say, the ball would have a flag on it that says, am I in turbo mode? And, if you hit like a level 3 block, you switch turbo mode on, and then all the logic for velocity just gets doubled somewhere else. And then you maybe clear that when the ball dies or something, so that it doesn't have a compounding effect. Multi-balls are always good fun. I like guns. If you can have your bat fire a gun and shoot the bricks to make the game much easier, that would be cool. I just kind of mentioned the speed modifier thing. Right, what other things could you do? You could maybe do things with graphics to make your because remember that the baseline Pong that I've given you as a starting point, just so you can get the basic, main loop and timing logic in. It just draws simple black canvas rectangles. That's rubbish, and it's easily improvable. You could obviously, you saw from Pong, you could change the color, use gradients, or you could actually load in proper graphics. You go and find like a nice, a bitmap somewhere, someone's drawing of a nice looking bat, and just bring that into the game. Or a nice background image. We saw some of those as well, maybe even a scrolling background. It's not too hard to do it. So yes, if you want to use sprite graphics, that would be cool. And remember, I've taught you about sprites, so in theory you know enough to use sprites instead of canvas primitives. But if you're going to do sprites, you're going to maybe want to have like a bat sprite, a ball sprite, a brick sprite, multiple sprites in other words. Now the thing about sprites is that to make the game be safe, you want to preload them all. Now I gave you logic, there's logic on the previous homework exercise that preloads the ship sprite to make sure that that sprite gets loaded before we start trying to draw anything. It's a bit more complicated if you have multiple sprites, because basically you need to set up multiple preloads and then wait for them all to finish. It can be done, and if you think about it, you should be able to do it. But if anyone wants, I've got a piece of code somewhere that I'll try and look out that basically does that for you. It's a version of the preload where you can give it multiple files and say, look, preload all of them, and then run my function when it's all done. And you could do that at the start to let you load multiple sprites. So I'll try and put that as an announcement or a file somewhere for anyone that wants to try it. And other things to top this off. This is the kind of general things you can do to Breakout to just make it better as a game, to make it seem more kind of fluid, more engaging, just a bit more fun, or as these people call it, make it juicier. Has anyone seen the juiciness video? No? Good, that means I won't be wasting your time. So this is just a video I found of some people actually talking about how to make Breakout be a bit better as a game. And I think it's quite instructive, so I'll show it to you. But because I'm just kind of showing someone else's video, I'll stop this recording and I'll start a fresh recording, because this is like not my content anymore, as it were. Although I will talk over it because I disagree with them about a couple of things. But anyway, we'll get to that. All right.